Hi all, I am K. Surya, working as Assistant Professor in the Department of ECE at SNS College of Technology. So in this video, let us see about a few basic principles of JFET. So a JFET is a three-terminal device in which the voltage is applied at one terminal to control the output current. The conduction current is by one type of carrier, either by the electrons or by the holes. Only the majority of the charge carriers are responsible for the current flow. Therefore, JFET is unidirectional. So the field effect transistor is a transistor that uses an electric field to control the current flow. These are devices with three terminals: source, gate and drain. The current flow can be controlled by applying a voltage to the gate, which alters the conductivity between the drain and source. They are also known as unipolar transistors as they involve signal carrier type operation. Single carrier type operation, which means they use either electrons or holes as charge carriers in their operation, but not both. There are two types of FETs. One is the junction field effect transistor and other is the metal oxide semiconductor field effect transistor or insulated gate field effect transistor. So JFET is a unidirectional electrical circuit. It's essentially a voltage driven device. A junction field effect transistor is a three-terminal circuit with an output current controlled by applying a voltage to one terminal. So it's also called as a transistor. So the symbol of the JFET is shown here. So for both P channel JFET and N channel JFET. So the difference here is the direction of current flow as shown by the arrow mark. So in the gate terminal. So this is a classification of field effect transistors. So field effect transistors are classified as JFET and MOSFET. JFET again it is classified into N channel and P channel, and MOSFET it is classified as depletion type and enhancement type. Again in each depletion and enhancement type it is classified as P channel and N channel. So now we will see about JFET alone, which has two types: N channel FET and P channel FET. So the construction of JFET is shown here. So in a N channel JFET, the body is of P type and the substrate is N type. It is doped with donor impurities, meaning that the flow of current through the channel is negative in the form of electrons. On the other hand, in P channel JFET, the body is of N type and the substrate used is of P type. It is doped with acceptor impurities, meaning that the flow of current through the channel is positive in the form of holes. Next we will see the operation of JFET. So when no voltage is applied across the source and the gate, the channel is like an open path for the carriers to flow through it. When a reverse bias is applied, the channel narrows by increasing the depletion layer and puts the JFET in the cutoff or pinch-off region. When zero gate voltage is applied and a small voltage is applied between the drain and the source, maximum saturation current will flow through the channel and be restricted by the small depletion region around the junctions. When a small negative voltage is applied to the gate, the size of the depletion region increases, reducing the overall effective area of the channel, and so the current flowing through the channel decreases. When a reverse bias voltage is applied, there is an increase in the width of the depletion region, due to which conduction current reduces through the channel. When the PN junction is reverse biased, little current flows into the gate junction. When the gate voltage is made more negative, channel width decreases until no more current flows through it, and the FET is said to be in the pinched off region. The voltage at which the channel almost closes is called as the pinch-off voltage. So next we will see about the JFET characteristics. The VI characteristics curve, the P type and N type JFET is shown in the figure. So the voltage is VGS represents the voltage between the gate and the source, and the voltage VDS represents the voltage between the drain and the source. So JFET has different stages of operation depending on the input voltages, and the characteristics of JFET in different regions are explained as follows. So it operates in ohmic region, saturation, cutoff and breakdown regions. So ohmic region is if the voltage across the gate and the source is 0, then the depletion region of the channel is tiny, and this region it acts as a voltage controlled resistor. Next one is pinched off region. It is also known as cutoff region. So JFET enters this region when the gate voltage is negative, then the channel will close, hence no current flows through the channel. Next one is active or saturation region. So in this region, the channel acts as a good conductor which is controlled by the gate voltage. Breakdown region. So it's the drain to the source voltage is very high. Then the channel of the JFET breaks down and uncontrolled maximum current passes through the device. So FET has several advantages over BJT. So the current flow between is due to majority carriers only, and it's immune to radiation. It has high input resistance and it is less noisy. So no offset voltages at zero drain current, and it has high thermal stability. Disadvantages of FET over JFET are FET have a drawback of smaller gain bandwidth product compared to BJT. Next we'll see few applications of FET. So JFET has a high impedance. These are low power consumption devices and they are smaller in size, have more gate current and have low modulation distortion. So with regards to these advantages, there are many applications of JFET, which are it is used as a switch, amplifier and buffer. It is used in digital circuits because of their small size, and it is used as a chopper. It's also used in oscillatory circuits because of its low frequency, and it is used in cascade amplifiers and RF amplifiers. It is used in communication equipments because of their low modulation distortion. It is used as voltage control resistors in operational amplifiers. Let us take up some assessment questions. Which of the following statement is true about FET? The choices are: it has high output impedance, it has high input impedance, it has low input impedance, and it has does not offer any resistance. So the answer is it has high input impedance. Comparing the size of BJT and FET, choose the correct statement. Yes, the options are BJT is larger than FET, BJT is smaller than FET, both are same size, and it depends on the application. Yes, the answer is BJT is larger than FET. What is the main advantages of FET which makes it more useful in industrial applications? So here the answer is small size. Thank you for watching this video.